Hello again. Today we are learning 6.4, solving polynomial equations. And our first technique is to solve by graphing. So you can pause the screen now and write all these steps down for the calculator. I will be showing you shortly how to do it on the calculator myself. So we're going to switch screens here. So let's see here. We want to go back to our board. Actually, I just did that a little too soon. We want to go here to this screen, and this is the first example we're going to be doing today. It is x cubed plus 3x squared equals x plus 3, and actually when you want to solve with the calculator, it's very easy. You don't want to manipulate the problem at all. We're actually going to enter it into the calculator like it is. We are going to enter the left-hand side into y1 and the right-hand side into the y2 of the calculator, and actually ask the calculator to find the intersection of those two. So we will be moving there now. And here is my calculator, and again the steps are on the board. The first thing I want to do is go to my y equals, and as you can see, actually you probably can't see, but I will turn the lights off here so you can see better. Hopefully now you can see that better. There is already something written in my y1, so I'm just going to clear it out. And like I said earlier, I want to enter, and by the way, I just went to my y equals menu here. I want to enter the left-hand side of the equation, which was x to the third power plus 3x squared. That was the part of the equation that was on the left-hand side. And in y2, I'm going to enter x plus 3, which was the part of the equation that was on the right-hand side. And that's pretty much it. Then we're going to hit the graph. And at this point, it might become necessary for you to adjust your window. You can kind of see that my window is all crazy right now. There's some stuff happening in here, and I can't really see what it is. So that means that I'm going to have to adjust my window. My first option is to go to my zoom standard, which is just the zoom key, and then option number 6 for Z standard. I'm not sure that's going to do what I want it to do, but actually it worked out nicely. And you can see now that the graph is crossing in 3 spots. It's crossing here, it's crossing there, and it's crossing there. And my job is to find these points of intersection. So I do that by going second, trace, and now I'm going, and this is the same menu that we've been using to use the zeros to find the maxes and the mins. This is the same menu, only now we're going to be using option number 5 for intersection. When you do that, you will notice that it begins to ask you a series of 3 questions, the first of which is first curve. It's asking you what the first curve should be. And so all you have to do is make sure that in the top left corner, it says y1. Okay? Also, the cursor should be blinking somewhere in the vicinity of where you think the intersection is. So I'm pretty sure that the first intersection I see is in this area. So I'm going to use my arrows, and you can see that it's moving so that it's blinking in the general area of where I think it's going to be. I've confirmed y1, so I'm going to hit enter. Now it's asking me for the second curve, and you will see that in the second curve it says x plus 3, which is what we put in y2. As long as that says y2, then we're good to go. We hit enter. And the last question is it's going to ask you to guess. And of course we hit confirm by hitting enter. It takes a little second, and it says that x equals -3. That is the first intersection. So that means that for our response over here for our solution, we're going to get x equals -3. And we're going to do that 2 more times because there are 2 other solutions. So now I'm going to do it again, second, trace, option 5, and this time I'm going to move the cursor so that it's blinking in this area because that's where the other intersection is. So I'm just using my arrows to travel over there. Now that I'm in the general area, I hit enter for y1, it's the correct y1. y2 is correct, hit enter again. And now when it says guess, hit enter again. And now it's telling me that that intersection point is -1. So we already had -3, now we're adding -1. And the last one We'll do it one more time, second trace intersect, and again, I want my cursor to be blinking over here somewhere because that's where I see the other intersection. So I'm just using my arrows. It's now blinking in that general area. My Y1 is correct. My Y2 is correct. I ask it to guess by hitting enter. And now we have x equals 1 as my third and final solution. So those are the three solutions that I get by using the calculator. Sometimes it'll be a decimal and sometimes it won't. If it's a decimal, just make sure that you round it to at least 2 decimal places. And those are your solutions. So now I will have you try one. I'll turn the lights back on so you can see me. And this is your example to do. And we're going to move on now to the other part of the lesson, which is not only can you solve polynomials by graphing, you can solve them by factoring. And so here are some formulas that you should know. This is a formula you should have had from last chapter. So there's a difference of 2 squares. We already proved that one. Also want to just kind of verify it for you today. So here we go. What we do to verify that it's true is FOIL. So first times first is a squared, a times a. Outside times outside is positive a times positive b, which is a positive ab. Inside times inside is a negative b and a positive a, so negative ab. And last times last is a negative b times a positive b, which is a negative b squared. You will notice that the two middle terms here, positive ab, negative ab, cancel. They equal 0. And that is how we in fact get a squared minus b squared. So that's how we verify that that is in fact true. Then we also have these two, and again we are going to verify them here together. It will probably take a little bit more effort than what I just did, but basically now you have 3 terms, not 2, so you can't really FOIL it. But we know that we have to take a multiplied by all of this, a times a squared plus ab plus b squared, and also negative b times a squared plus ab plus b squared. Okay? And now we can do it this way. A times a squared is a cubed. A times ab is a squared b. A times b squared is ab squared. Then we have negative b times a squared, which is negative a squared b. Then we have negative b times positive ab, which is negative ab squared. And lastly, negative b times positive b squared is negative b cubed. And then we can try to combine all of our like terms, and we have a cubed, we have an a squared b and a negative a squared b, so they cancel. We have a positive ab squared and a negative ab squared, so they cancel, and then we just have minus b cubed, and that is how we verify the first one. And we'll do a very similar process to verify the second one here. Again, we're going to take the positive a and multiply it by a squared minus ab plus b squared. And then we'll take this positive b and multiply it by a squared minus ab plus b squared. And again, we are trying to verify that this in fact is a cubed plus b cubed. So again, a times a squared is a cubed. A times negative ab is negative a squared b. A times b squared is a positive ab squared. Positive b times a squared is a positive a squared b. Positive b times negative ab is a negative ab squared. And positive b times positive b squared gives us positive b cubed. Then we want to combine our like terms. We have a cubed right there. We have a negative a squared b and a positive a squared b, so they cancel. We have a positive ab squared and a negative ab squared, they cancel. And of course you're left with plus b cubed. And that is how we prove that guy. I will also give you one other, not really a hint, it's more of a tip, I guess. An easy way to remember the formulas is this thing called SOAP. S-O-A-P. You know, like soap, like when you take a shower and stuff. You use SOAP. So the S stands for same. The O stands for opposite. And the AP stands for always positive. So that acronym helps us remember this breakdown, because if you look at the difference of two cubes and the sum of two cubes, they're pretty much the exact same thing. This is a minus b, this is a plus b, this is a positive ab, and this is a negative ab, and that's the only difference. So this acronym helps you remember that. So if you have a cubed minus b cubed, the S, meaning same, is telling you that this sign, negative sign, is the same as this guy. And so here, because this is a plus, it's the same. So the very first symbol is the same. The O stands for opposite. So when you get to the second symbol, it's going to be the opposite of what it is here. So if this is a minus, the opposite is a plus. If this is a plus, the opposite is a minus. And then the last one, the AP, tells you that it's always going to be a positive b squared. So this last sign, this last symbol, will always be positive. So it'll always be plus b squared plus b squared. So it's just a nice way to remember that. So there we go. Also, as we're doing this, I want you to take a moment and copy this screen down. Pause it if you need to. These are some perfect squares that you should know because they're going to come up a lot in the next couple of lessons. A lot of these you already know, that 3 squared is 9, but I just want to make sure that you have them somewhere as a list. So perfect squares that you should know, perfect cubes that you should know. This list is a lot shorter because it gets bigger a lot faster, but just some things that you should know. So you should write them down in your notes. We're not going to stay there very long. And so now I'm going to use the difference of two cubes to factor this here. One of the first things that you want to recognize is the formula. So we should recognize 8 as being one of those perfect cubes that I just mentioned in the last board. So you want to rewrite it as x cubed minus 2 cubed, because 2 cubed is the same thing as 8. You probably want to identify that in this case the a is x and the b is 2. You don't need to include the negative in your b. The formula itself will already take care of that. So according to the formula, when I factor this, the formula says to do the same, right? I'm going to use SOAP here. So this is a minus, this is going to be a minus. So it's going to be a minus b. So it's going to be x minus 2. And then the rest of the formula says to do a squared. So a is x again, so it'll be x squared. And then because this is a minus, this will be a plus, according to the opposite of the SOAP acronym. So this will be a plus, and it's plus AB. So it means A times B. So 2 times x. So it'll be plus 2x. And then lastly, it's always positive. So it'll be plus and then B squared. So 2 squared, which is 4. And that is how I factor it. There's no more to do. This quadratic here is no longer factorable. This is the complete factorization for x cubed minus 8. So now I want you to try to factor this guy. So take a moment to do that. And we will move on to this example. This is basically an example where we're going to stretch the factoring just a little bit further. It's now asking us to solve the equation. Okay, so this is not saying to factor it, but to solve it. And when you solve something, you have to end up with x equals. You will notice that on this example back here, I didn't solve for x. I just factored it, and that's it. Well, the difference now is that they want me to actually solve for x. But I have to begin by factoring. So again, I will notice that 27 is 3 cubed. So I will write 3 cubed x cubed plus 1 cubed. 1 is one of those universal cubes. It's a cube. 1 cubed is 1, 1 squared is 1, 1 to the 5th power is 1. And I'll often forget to write the 1 as a cube, but there you go. When you have 2 cubes like this, it is helpful for you to write it as 3x quantity cubed, because now when I identify what A and B are, my A is actually 3x and not just the x. A lot of times students forget that, and B is 1. Again, I don't attach positive or negative to my B. The formula itself will take care of that. So using my SOAP, in order to factor this, I want to do the same. S is the same, so 1 plus. So I'm going to go A plus B, and A is 3x, and B is 1. So there's 3x plus 1. And then I'm going to get A squared. And this is where it gets interesting. Again, if you have the right A, it says A squared, which really means 3x squared, which is not 3x squared. It's actually 9x squared. A lot of times people forget to square both the 3 and the x. So this is actually going to be 9x squared. And then since this is a positive, this will be the opposite, which is a negative, and it's A times B, so 3x times 1, so I'll get 3x. And then always positive, the last one is plus 1 squared, or plus 1. So now it is completely factored, and you will notice in the directions, it not only said to solve it, but to define all the complex roots. Okay, and that's because I said earlier that the quadratic is not going to factor. The complex roots that they're talking about are going to come from this portion of the factorization. The first portion is actually pretty simple to solve for. You just go 3x plus 1 equals 0, and you subtract 1 divided by 3, and x equals negative 1/3. Subtract 1 divided by 3. That's the easy part. Doing this portion is not so easy. You have to use the quadratic formula for this. So here we go. X equals negative b plus or minus radical b squared minus 4ac all divided by 2a was the song. So again, I did a couple of tricky things there. I'm not sure if you followed that really, so I'll go over it again real quick. It says x equals negative b. So if b is already negative, then a negative and a negative make it a positive b. So basically it's always opposite. So if this is a negative, then this will be a positive b. If this is a positive b, then it'll be a negative b. So there's my x equals negative b plus or minus the square root, the radical, b squared, negative 3 squared is 9, minus 4 times a is 9, and c is 1, all divided by 2a. So now I'm going to simplify this guy, and this will be 3 plus or minus 9 minus 4 times 9 is 36. So, and 36 times 1 is still 36. So I'm going to get 9 minus 36, which is negative 27. Square root of negative 27. And now it might be clear why it was asking for the complex roots, because it's going to be imaginary. At this point, you want to break down your 27, which is 9 and 3. And the square root of 9 is 3. And the square root of 3 is just stays there. So now we can break this down into 3 plus or minus 3 root 3i for the negative divided by 18. And since 18 and 3 have a common factor, which I believe is 6, then we're going to get 3 goes into 3 once, 3 goes into 3 once, 3 goes into 18 6 times. So our final answer is going to be 1 plus or minus 1 root 3i divided by 6. And those are my complex roots, and this is my normal real root. Okay? So that is how you solve the equation by factoring. So now I'd like you to try these two. You can pause it at this point and do those examples on your own. We're going to move on to more factoring. There's another way that you can factor. This might look kind of scary to you, but it shouldn't scare you too much. We're going to do a little trick here to make this a little bit easier for us. You'll notice that this looks like a quadratic, but it's got x to the 4th and x squared instead of x squared. Normally we like to see the quadratics ax squared plus bx plus c. So this is a 2, this is a 1. And that pretty much looks like it got doubled. This 2 became a 4, and the 1 became a 2. But believe it or not, we can actually factor this like a quadratic, but we have to do one little thing first. We have to do this little substitution. Let's pretend, so let an imaginary, not an imaginary, but a different letter. So I'm going to pick u, it's different than x. Let me say that u is equal to x squared, which you might not like that, but just accept it. So if u equals x squared, then what would u squared equal? It would be x squared squared, which would become x to the fourth because you would multiply the exponents there. So now when we make that substitution, we can actually rewrite the original problem using u instead of x. So now, instead of x to the fourth, I can write u squared. Instead of x squared, I can write 2u, and then the minus 8. Now, this problem doesn't look too complicated. It looks a lot like the original quadratic. So we can solve it the way we always have. 1, 1. The factors of 8 are probably 4 and 2. And we want to go with a negative 4 and a positive 2, because if I do 1 times negative 4, it would be negative 4. 1 times 2 is 2. When I add those together, I get negative 2, which is what the middle term is. So that's my factorization. So this will become u plus 2 and u minus 4. And now at the very end, after you've done that part of the factorization, you need to remember to replace the u with the original substitution. We said that u was x squared, so really what we're saying here is this is x squared plus 2, and then x squared minus 4. Okay, and you should recognize the x squared minus 4 as a difference of 2 squares because it's x squared minus 2 squared. So technically, this should then become x minus 2, x plus 2, and then of course you have your x squared plus 2 over here. So now this is completely factored. Again, in this problem, it only wants you to factor, it doesn't want you to solve. So I'm done with this example, and now you can try these. Again, we're just factoring. All right, so our last example is taking it a step further from factoring and actually solving. So this is like what we just did. You have what looks to be like a quadratic, but not quite. We need to move this 12 to the other side, and now it's x to the fourth minus x squared minus 12 equals 0. So the difference between this and the previous example is the equal to 0 part, but we still need to factor it. So I have to make a substitution. So I will say that u equals x squared. So then u squared equals x to the fourth. I will rewrite my problem as u squared minus u minus 12 equal to 0. And when I factor that, 1, 1, we're going to use 4 and 3. And if I use negative 4 and a positive 3, I will get negative 4 plus 3, which is negative 1, and that's the middle term. So my factorization will be u minus 4 times u plus 3 equal to 0. And again, like we said earlier, we need to go back and replace the u with the x squared. So now we're going to have x squared minus 4 and x squared plus 3 equal to 0. And at this point, we would have been done in the previous example, but now we actually have to solve for x. So we use the zero product property, and we're going to take our first factor, x squared minus 4, and make that equal 0. And we'll take our x squared plus 3 and make that equal 0. Now you have a couple of options here at this point. You could factor the x squared minus 4 like we did earlier, and that'll be x minus 2, x plus 2. And then when you separate them each equal to 0, you'll get two answers. In this case, you'll add the 2 to both sides, so you'll get x equals positive 2. And in this case, you'll subtract the 2 to both sides, and you get x equals negative 2. So you'll have plus and minus 2 for your solutions. If you do it this way, you'll add the 4 to the other side, and then you'll square root, and you won't forget to put plus or minus 2, which is exactly the same thing. You get positive 2 and negative 2 this direction, or you get positive and negative 2 this direction. And at any rate, those are two of your solutions. In this case, you subtract 3, You can't factor this any further, so you're really stuck with x squared equals -3. And then when you square root both sides, you will not forget to put plus or minus. But this time, because it's a -3, you're going to get root 3i. The I is there because of the negative. So you have 4 solutions total, plus root 3i, negative root 3i, positive 2, and -2. And those are your solutions there. And so now you will do this example yourself, and when you've done that, you have completed this lesson. And thank you for watching. We'll see you soon.